Hey guys, in our day 2 set of notes, we're going to continue talking about how to show that a quadrilateral is a parallelogram. So we're going to put some of these methods that we talked about into practice. We have the same problem on your page a couple different times, and it looks like this. It says show that quadrilateral KLMN is a parallelogram. We're going to try this out with 4 of the methods. We're going to work through the same problem in multiple different ways. So you're going to be doing different work to manipulate on this problem. The first way I want to show is that both pairs of opposite sides are congruent. So our method that we're going to show this time is show both pairs of opposite sides are congruent. Now, how do we show they're congruent? We show that they have the same length. So remember, length is our distance formula. So D equals, and then we'll have a big square root. We're going to subtract the two x values and square it, and then subtract the two y values and square it. So let's try this. Let's look at KL and then MN. Let's see if we can test if those are the same length. So for KL, notice I don't put the bar on top because I'm talking a number value. I have 4 minus 2, quantity squared, plus 4 minus 2, quantity squared. So 4 minus 2 is 2. 4 minus 2 is 2. So 2 squared is 4. So I have 4 plus 4 is the square root of 8. Now remember, you can go ahead and simplify that. But if we're trying to just test if something's the same, it's okay if we just leave it like that. So then I'm going to check with MN. So big square root, I'm going to subtract the x values. So 6 minus 4, quantity squared, and then 0 minus a negative 2, quantity squared. So 6 minus 4 gives us 2. 0 minus a negative 2 also gives us 2. 2 squared is still 4, so 4 plus 4, we end up with the square root of 8. So both of them are the square root of 8, so what that tells us is that KL is congruent to MN. Let's see if we can do that again. So we're going to look at KN this time. So if I'm subtracting the x values, I have 2 minus 4, quantity squared, plus 2 minus a negative 2, quantity squared. So 2 minus 4 gives me negative 2 squared, and then 2 minus a negative 2 gives me 4 squared. So negative 2 squared is 4, 4 squared is 16. I get the square root of 20. Let's see if we get that same thing when we do LM. Big square root. So I have 4 minus 6, quantity squared, plus 4 minus 0, quantity squared. So 4 minus 6 is negative 2, and then 4 minus 0 is 4. So negative 2 squared is 4, and 4 squared is 16. I end up with the square root of 20. So then that tells me, since those are the same, that KN is congruent to LM. So the first thing we wrote was show both pairs of opposite sides are congruent. That was the method we used. We now need to write a conclusion. Since both pairs of opposite sides are congruent, KLMN is a parallelogram. Okay, there is your conclusion. I want to point out to you that that is one problem. We've just completed one problem by doing the distance formula and then coming up with our conclusion. All right, you see a familiar parallelogram here. We are going to actually do two methods on this same page. So I'm going to split my page down the middle like this. You can divide your paper up however you would like, but I'm going to do two different methods on the same page. So on the left-hand side, I'm going to show diagonals bisect each other. So if I want to show that diagonals bisect each other, I need to use the midpoint formula here. Because if they bisect each other, they'll both have the same midpoint. So our midpoint formula, remember, is where we're finding the average of the point. So I have the two x values, and then I have the two y values. So in this case, I'm going to find the midpoint, and this is of the diagonal. So I want to go from K to M. So midpoint of KM. So my x values are 2 plus 6. I'm adding them together and I'm dividing by the number that I have. My y values are 2 plus 0. So I get 2 plus 6 is 8. 2 plus 0 is 2. So I end up with 4, 1 for the midpoint of KM. Let's see if the same thing happens on the midpoint of LN. So my x values are 4 plus 4. And my y values are 4 plus negative 2. So 4 plus 4 is 8. And then 4 plus negative 2 is 2. I get 4, 1. So I can say, since diagonals bisect each other, KLMN is a parallelogram. All right, on the right-hand side, I'm going to use the method of showing that opposite sides are parallel. So show both pairs of opposite sides are parallel. And to do that, we need to show that their slopes are the same. So our slope formula, remember, is y2 minus y1 over x2 minus x1. So let's see. Let's start with KL again. So KL, I have 4 minus 2 over 4 minus 2. Subtract the y's. subtract the x's. So 4 minus 2 is 2, 4 minus 2 is 2, 2 over 2 is 1. Okay, I need to see that MN is going to have that same slope. So subtract the y's, I get 0 minus a negative 2, and then 6 minus 4. So 0 minus a negative 2 is 2, 6 minus 4 is 2, 2 over 2 is 1. Okay, so far so good. KL is parallel to MN. Now let's try KN. So subtract the y's, I get 2 minus a negative 2. And then subtract the x's, I get 2 minus 4. So 2 minus a negative 2 is 4. 2 minus 4 is negative 2. So I have 4 over negative 2, which is negative 2. Okay, then let's try LM. So I have 4 minus 0 for my y's, and then I have 4 minus 6 for my x's. So 4 minus 0 is 4, 4 minus 6 is negative 2, 4 divided by negative 2 is negative 2. So here, KN is parallel to LM. So then our conclusion, we can say, since both pairs of opposite sides are parallel, KLMN is a parallelogram. Let's move this out of the way. There we go. Is a parallelogram. So we've also proven using this method. Now I told you we were looking at 4 methods. We're not actually going to do the 4th method, but remember that a 4th method we could use is to show that one pair of opposite sides is both congruent and parallel. So what you could do is take KL and MN that we just found the slopes of and showed that they were parallel, and then go back to this one and look at KL and MN, and we found that they were congruent. So we've shown that one pair of opposite sides is both congruent and parallel. So we're not going to redo that work. That's another method. You just group your work differently. Okay, so this page is just a summary page, so I think it's a really great resource. This may be something that you want to star, highlight, somehow you know to go back and look. If you want to show that both pairs of opposite sides are congruent, you would use the distance formula. And you would use that a total of 4 times. If you want to show that both pairs of opposite sides are parallel, you would use the slope formula. And you would use that a total of 4 times. If you want to show that one pair of opposite sides are both parallel and congruent, you would use the distance formula. Two times. And then for the same side, the slope formula. So again, 2 times. If you want to show that diagonals bisect each other, you would use the midpoint formula. This would be a great place if you don't have those formulas memorized, also to write them out here. The next page has a construction. We're going to do that together in class. If you have questions, come in and see me. I will see you in class.